So you've replaced your speakers, and now the next step to your system build is putting some power behind those speakers. But dropping $300 plus on a multi-channel amplifier is not an ideal option, but neither is picking up that Walmart special amp next to the hardware section. An entry-level amp might be all you need, like the Soundstream Arachnid Series AR4.1200 Class AB 4-channel amplifier. Ideally used for your front and rear speakers for solid mids and bass, the AR4.1200 is incredibly affordable, coming in around the $75 range. The same price as that bad Tinder date you went on last Wednesday. Inside the box is a warranty card, user manual, fuses, hardware, and a 4-channel Arachnid amplifier. The most unique thing about the Soundstream amplifiers, besides their solid old school reputation, is their LED lighting system, featuring blue illumination beneath the Soundstream graphic. This makes for a very cool look in low light situations. The Arachnid AR4.1200 has decent adaptability. It was ideally designed to power 4 speakers, but according to Soundstream, you can bridge channels 1 and 2 and channels 3 and 4. So you can also run subwoofers on these channels. It seems that you can also run a 5-channel setup with 2 speakers on channels 1 and 2 and running stereo speakers on channels 3 and 4 while running a bridged output to a subwoofer. This will require you to use caps on the mids and a coil on the sub. Soundstream rates the 4-channel Arachnid's power 150 watts RMS by 4 channels at 2 ohms, 120 watts RMS by 4 channels at 4 ohms, and 300 watts RMS by 2 channels bridged at 4 ohms. But as always, let's test it out ourselves. But first, I want to take a look inside the amplifier. The power supply is okay, not as much going on as I thought there'd be, but we've seen worse. The first test we ran was 2 channels at 4 ohms, 40 hertz, 14.5 volts. We got a clean waveform at -7 dB. 42 watts RMS on the SMD, 13.6 volts of output on the Lumi, while drawing 11.66 amps of current, and 46 watts RMS on our HP 8903B audio analyzer with 0.22% distortion. Next, 2 channels at 4 ohms, 1 kHz, -6 dB, 14.5 volts, our SMD picked up 43 watts RMS, 15.16 volts of output on the Lumi, while drawing 12.56 amps of current, and 57 watts RMS on our HP with 2.6% distortion since we were on the edge of clipping. Going down to -7 dB, distortion dropped to 0.46%, and RMS dropped to 47 watts. Third test, single channel at 4 ohms, 1 kHz, -6 dB, 14.55 volts, our SMD picked up 46 watts RMS, 15.38 volts of output on the Lumi, while drawing 6.72 amps of current, and 59 watts RMS on our HP, with 1.06 distortion. Going down to -7 dB, distortion dropped to 0.24%. Fourth test, single channel at 4 ohms, 40 hertz, -6 dB, 14.55 volts. Our SMD picked up 49 watts RMS, 15.15 volts of output on the Lumi, while drawing 6.87 amps of current, and 57 watts RMS on our HP, with 1.28% distortion. Going to -7 dB, distortion dropped to 0.14%. Fifth test, single channel at 2 ohms, 40 hertz, down to -8 dB, 14.51 volts. Our SMD picked up 64 watts RMS, 11.87 volts of output on the Lumi, while drawing 10.43 amps of current, and 71 watts RMS on our HP, with 0.24% distortion. Raising to -7 dB, distortion spiked to 2.1%. Sixth test, single channel at 2 ohms, 1 kHz, -7 dB, 14.5 volts. Our SMD picked up 68 watts RMS, 13.31 volts of output on the Lumi, while drawing 11.16 amps of current, and 89 watts RMS on our HP, with 1.57% distortion. Going down to -8 dB, distortion dropped to 0.55%. Seventh test, 2 channels at 2 ohms, 1 kHz, -8 dB, 14.5 volts. We were beginning to see some unhealthy distortion in the waveforms here. Our SMD picked up 56 watts RMS, 11.70 volts of output on the Lumi, while drawing 19.1 amps of current, and 68 watts RMS on our HP, with 4.53% distortion. Going to -9 dB, distortion dropped to close to 1%. Eighth test, 2 channels at 2 ohms, 40 Hz, -8 dB, 14.43 volts. Our SMD picked up 59 watts RMS, 11.62 volts of output on the Lumi, while drawing 19.67 amps of current, and 68 watts RMS on our HP, with 1.6% distortion. Going down to -9 dB, distortion dropped close to 0.96%, with a much lower RMS of only 50 watts. Our final test was on frequency response, and this thing was flat as a ruler. Overall, this isn't a bad amplifier, it's just inaccurately rated. Don't forget, it's under $80. It'll do a fine job powering mid-level aftermarket speakers. For adjustments, channels 1 and 2 feature variable 120 Hz to 3 kHz, 12 dB high-pass crossovers. Channels 3 and 4 feature both variable high-pass and low-pass filters between 120 Hz to 3 kHz, 12 dB per octave. The amplifier does not feature remote bass control. Use the low-level RCA inputs to connect to your head unit. It will accept up to 6-volt audio inputs. So for lower-powered stock stereos, you can solder RCAs for direct speaker-level inputs, or use a line output converter if your stock stereo exceeds 6-volt outputs and has no RCA preamp outputs. A major con I found with this amplifier was in order to access the terminals, you have to remove the end cap, which isn't uncommon, but was kind of a pain on this specific amplifier because the screw holes are on the side and about ½ an inch inside the cap itself. So consider this when access is limited after the amplifier is installed. Soundstream recommends a minimum of 8-gauge power and ground leads. Check out our amplifier installation kits online, link in the bio. Dimensions of the amplifier are 15 3/4 inches in length, 8.5 inches in width, and 2 inches in height. Be sure to go to qualitymobilevideo.com to get all of your car, audio, and video gear with us today. Links for everything in the bio below. If you enjoyed this video, go ahead and click that like button, but if you hated it, click the dislike button. Join the conversation below and subscribe to our channel if you're new. Thanks for watching.